Hi, today Joanna and I will be discussing Cody's concrete architecture. We first began by looking at our existing conceptual architecture that we had constructed by looking at Cody's webpage. This had a layered style featuring 4 layers with dependencies between adjacent ones and only unilateral dependencies. From this slide, you can see that it was a very simple diagram with very little interlayer communication. There are many things missing from these diagrams, and that was made apparent once we started looking at the source code. We realized that there was a need for a new subsystem because there was a folder that was referenced by every layer in the system. We also saw that there was communication, there was dependencies between all the layers, which would mean that we needed bilateral connections or dependencies. And finally, we realized that we needed many more connections between the layers. Using Understand, the application for dependency graphs, we were able to analyze the source code and create this diagram by placing every file and folder into its own subsystem. And as you can see, we are left with a much different architecture diagram than our existing conceptual one. It is no longer layered, and there are clearly dependencies between every layer. And we have the addition of utils, which is a new subsystem, which is referenced by every other layer and is essentially a shortcut for the Cody system to access files that it uses frequently. By using our Understand diagram, we were able to create this high-level architecture diagram showing the 5 subsystems, 4 of which were already existing in the conceptual diagram, and our new layer called utils. As you can see, the client layer, the business layer, the skins layer, and the data layer have all gained dependencies, and they are all connected with each other. There are many differences between the conceptual and concrete architectures of Cody. First, we have a new subsystem named utils, which consists of a repository of commonly used scripts by other subsystems. Given the massive amount of dependencies throughout the entire source code and this repository, we thought it would be smart to make it its own subsystem. Next, we have a list of new dependencies. In the client layer, the platform repository, which handles what device the user is using, is dependent on the GUI elements and the window manager folders within the source code. This adds a new dependency, whereas before the skins layer was dependent on the client layer. Now it's a bidirectional dependency. Next, previously the business layer depended on the skins layer, but now there is a dependency where the user input in the skins layer is dependent on the web server, interfaces, and add-ons folder in order to determine how to process this information. Next, there is a new dependency between the data layer and the business layer, whereas before the data layer depended on the business layer. Now the business layer uses the metadata from data layer in order to format its interfaces, giving a bidirectional dependency. Next, we have the data layer and the client layer's new bidirectional dependency. This is specifically with the metadata repository in the data layer. It could be a redundancy where platform-specific metadata could be stored specifically in the client layer, but instead Kodi has it all in the data layer. The data and skins layer are connected only in the concrete architecture. We saw a new bidirectional dependency where between the sources directory of the data layer and the Windows Manager directory of the skins layer. Next, we also saw a bidirectional dependency between the GUI elements of the skin layer and the sources directory of the data layer. Finally, the metadata and the views directory of the data layer are also bidirectionally connected to the GUI elements, Window Manager, and the user input directories of the skins layer. Next is a new bidirectional dependency between the business layer and the client layer. We see this as specifically being due to the add-ons, the player core, web server, and interfaces directories, which would have platform-specific functionality and would need a connection with the client layer.
Now we will take a look at one of the subsystems. In this case, we're looking at the business layer, which handles the interface between the user's request to the system and the system itself. From our original conceptual view of Kodi, the business or the interface layer contains the Python module, web server module, and player core module, which handles server access, libraries or add-ons, scripts for connections to streaming servers, and reading or playing of video and audio. Using Understand, we generated the diagram below with all dependencies between subsystems. We found that the original proposed unilateral architecture for the business layer lacks several dependencies, including a new subsystem, utils. We found 4 main divergencies from our conceptual architecture. Client layer depends on business layer, data layer depends on business layer depends on skins layer, and business layer depends on utils. Using Understand, we found that the client layer has around 400 dependencies on the business layer, specifically on the DLL add-ons, event server, player core, interfaces, and web server. Now looking at the data layer. The data layer gains several hundred dependencies on the business layer, specifically towards the event server, the player core, DLL add-ons, interfaces, and web server. Also, the business layer gains several thousands of dependencies on the presentation layer. DLL add-ons depend on dialogues within the GUI element subsystem and Windows Manager. Also, user input was also dependent on that. And the final major divergence in our conceptual architecture was the addition of the utils subsystem. With dependencies with every other subsystem, utils provides the entire Kodi software with repeatedly used files. This is very important since so many layers need access to similar content at the same time. Now let's take a look at one of our use cases, playing music from CD. The user uses the application through client layer. The input for playing CD is registered on presentation layer and passed on to business layer, and at the same time the data layer reads the CD. Following by that, the data is fetched by the business layer and it starts to play, and it finishes when the music ends. From investigating the concrete architecture of Kodi, we find a few neat emergent properties. Firstly, whole new subsystems, like util in this case, can be exhibited in the real-world project which were not incorporated in the conceptual architecture of a project at inception. Secondly, the interconnection of subsystems with a project's concrete architecture exhibit more dependencies than foreseen in the conceptual counterparts. And finally, we see that a one-way dependency can become a two-way dependency between subsystems when taking an architecture from conceptual view to concrete view. To conclude, through utilizing Understand on source code and analysis on the official architecture documentation of the Kodi player, we delved into these subsystems, examining their functions and interrelations. We acknowledge that the initial conceptual architecture was not flawless. We have identified 6 unexpected dependencies and 1 new subsystem, utils. In general, we got a glimpse at the difficulty of casting a real code-based architecture onto conceptual architecture subsystems.